Hello dear children, and welcome all of you to the class of mathematics. We have started with lesson number 1, real numbers, and in the previous video lesson we discussed about fundamental theorem of arithmetic. The first topic of the lesson is Euclid's division lemma, and I didn't take that topic because this topic is being deleted from our syllabus for this academic year. So we have directly started with fundamental theorem of arithmetic, which states that every composite number can be expressed as a product of primes, and this factorization of a composite number is a unique factorization apart from the order in which the prime factors occurs. Based on this fundamental theorem of arithmetic, we have our exercise 1.2, and we will begin with this exercise today. In the exercise we have the sums which are based on what you have already learnt in standard 8th and standard 9th. This is a very simple method of prime factorization of a composite number. So question number 1 is, express each number as a product of its prime factors. And about prime numbers we have already revised in the last video lesson. Our first number is 140. So let's see how we'll factorize this. We have to find factors of 140, and those factors should be prime factors. So we'll write this 140, and then factors of 140 are 2 into 70. Again we can factorize 70 as 2 into 35. Again we can factorize 35 as 5 into 7. And 5 and 7 both are prime numbers, so the factorization process stops here. So we observe that the factors of 140 are 2 into 2 into 5 into 7. We will write 140 is equal to 2 into 2 into 5 into 7. Now since 2 occurs for 2 times, we can also write it like this: 140 is equal to 2 square into 5 into 7. Alright, now this is one method, and alternatively, or suppose if you want to do it by the regular method which we have been using since our standard 8th, so we can factorize 140 in that manner also. We'll write this 140 in this way. So 270 is a 140. Again we can factorize 70 as 2 into 35. Then we will factorize 35 by 5. So 5 7s are 35, and then 7 1s are 7. So we'll write 140 is equal to 2 into 2 into 5 into 7. Alright, so this is our routine old way of factorization of a composite number, and this is called as prime factorization, because we keep factorizing the number till we get all prime factors. The first method is called as tree factorization method, and the second method is our routine prime factorization method. Alright, let's go ahead. This is the third question from exercise 1.2, question number 1. And the number which is given to us is 3825, and we have to find the prime factors of this composite number. So we'll first write 3825. This is our number. Now since at the units place we have the number as 5, so how will we start our factorization? We will start with 3. You have to first find the divisibility test by 3 and then by 5. So 3825 is divisible by 3, so you can write 3 into 1275. Then again we can factorize 1275 as 3 into 425. Again we can factorize 425 as 5 into 85. You can factorize 85 again like 5 into 17, and 17 is a prime number. So here our factorization process will end. So let's find out what are the factors of 3825. We'll collect all our prime factors, that is 3, into 3 into 5 into 5 into 17. So we'll write 3825 is equal to 3 into 3 into 5 into 5 into 17, and as I said, we can also write it like this: 3 square into 5 square into 17. The same sum can be done by the prime factorization method. So just have a look over here. Again we can write 3 into 1275, then 3 into 425, then 5 into 85, then 5 into 17, and the last is 17 into 1. So in the same manner we have written the factors of 3825. Finally 3 square into 5 square into 17. So this is how we can find the prime factors of the composite number. I hope you understood this. This is since we are doing it since so many days, so I don't think this you will find difficult. It's a easy concept. All right, next is this number 7429, and we have to find prime factors of this number. This is the fifth question from question number 1, exercise 1.2. all right, so 7429, and we will find the factors as 17 into 437. Again we can find factors of 437 as 19 into 23. So 17, 19 and 23, all three are prime numbers. So we can write 7429 is equal to 17 into 19 into 23. These are the prime factors, because we cannot further factorize 17, 19 and 23. All the three are prime numbers. And similarly, by the other method of normal factorization, we can do it like this: 17 into 437, then 19 into 23, and 23 ones are 23, and the factors are 7429 is equal to 17 into 19 into 23. All right, let's move ahead. This is question number 2, and the question is: find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of two numbers. Children, I told you that fundamental theorem of arithmetic, this is useful to find the LCM and HCF of the numbers. LCM stand for least common multiple and HCF is highest common factor. Let us understand how to find out LCM and HCM and then verify the relationship between LCM, HCF and the pair of given two composite numbers. So this is the second sum from question number 2, and the pair of numbers which is given to us is 510 and 92. So let's consider 510 first, and our first step will always be find the prime factors of the given composite numbers. So let's start finding the factors of 510, and this is the other number 92 which we have taken. So we'll begin with factorizing 510 first. So we'll factorize it like 2 into 255. Now for 255 you have to begin factorizing it as 3 into 85. Again you can factorize 85 as 5 into 17, and now these are all prime factors. So you can write 510 in the form of its prime factors as 2 into 3 into 5 into 17. Alright, let's start factorizing the other number, that is 92. So we will start with 2. This is 2 into 46. Then again we will factorize 46, and when you factorize 46 it is 2 into 23, and 23 is a prime number. So we have to stop here. We cannot go ahead with number 23. So factors of 92 are 2 into 2 into 23. And since 2 repeats here, so we can also write 92 is equal to 2 square into 23. Now once you find the prime factors, after that let's understand how to find out LCM and HCF. So look at this. These are our factors. 510 we have written all prime factors. 92 we have written all prime factors. Now when you find out LCM of 510 and 92, what you have to see is first check out the least factor there, the smallest factor. Our smallest factor is 2. Then you check out what is the highest power of the smallest factor. Here the highest power is 2 raised to 2. So we will write down that number first. Then the next prime factor greater than 2 is 3 there, and 3 has occurred only for one time, so we will write 3. Then the number is 5. It is only for one time, so we will write 5. And after that we will write 17 and then 23. So LCM, when you find out, first you will find out the smallest factor. You will find out the greatest power of that smallest factor and then write it down. And after that subsequent next factor you have to check out, and every time you have to see what is its highest power, and accordingly you will place the number. So we have written 2 square into 3 into 5 into 17 into 23, and if you multiply this, the multiplication is 23460. That is the LCM. Now what is the meaning of highest common factor? Now highest common factor, for that just check out all the prime factors once again. You will observe that in both the factorization of 510 and 92, 2 is the factor which is common. After that if you check, none of the factors are common. So HCF is the factor which is common in the prime factorization of both the numbers. Since 2 is common, so 2 is HCF of 510 and 95. Let's now verify. We have to verify that the LCM and HCF of the two numbers is equal to the product of two numbers. So LCM into HCF is equal to 23460 into 2. That gives us 46920. And if you multiply 510 and 92, that will also give you the product as 46920. So we have verified that LCM into HCF is always equal to the product of the two numbers. And this is an important, you can say, relation, and you have to keep this in mind. Alright, let us move to the next sum. So the next set of number which is given to us is 336 and 54. So let's begin with the number 336 and start the prime factorization method. So 336 we will first factorize it. So we can factorize it as 2 into 168. Again we can factorize 168 as 2 into 84. Again we can factorize 84 as 2 into 42. Again 42 is 2 into 21. Again 21 we can factorize as 3 into 7, and here the process of factorization ends. Children, I have used the method of tree factorization everywhere. If you find the other method easy, you can go by that method also. So it is not compulsory that you have to solve the sum by this tree factorization method only. You can make use of a routine prime factorization method. Alright? Okay, so let's collect all the prime factors of 336. So it is 2 into 2 into 2 into 2 into 3 into 7. So we'll write it like this. 336 is equal to 2 into 2 into 2 into 2 into 3 into 7. So we can write it in this manner. 336 is equal to 2 raised to 4 into 3 into 7. Alright. Let's take the other number. Our other number is 54. Let's factorize this. So this is 2 into 27. We can factorize 27 as 3 into 9. And we can factorize 9 as 3 into 3. Alright. So we can collect all the factors of 54, and the factors are 2 into 3 into 3 into 3. So we'll write it. 54 is equal to 2 into 3 into 3 into 3. So we can write 2 into 3 raised to 3. That is 54 factors of 54. Alright. Now the next step is to find out the LCM and HCF of 336 and 54. So these are our factors which we have written. For LCM, I told you, first you check out which is the smallest factor there. Our smallest factor is 2. What is the highest power of 2 there? The highest power of 2 is 2 raised to 4. So we will first write that. Next to that, which is the prime factor? It is 3. What is the highest power of 3 here? It is 3 raised to 3. So into 3 raised to 3 we will write. Alright, what is the next factor? Next factor is 7, and there is no question of highest power because we have only one 7 left there. So we will write 7, and therefore when you multiply 2 raised to 4 into 3 raised to 3 into 7, we get the number 3024, which is LCM of 336 and 54. Alright, now let's move towards finding the HCF. For that, let's find out what is common factor in both the numbers. So this 2 is common. Then if you check out, 3 is also common, and then nothing. So 2 and 3 are the two common factors. So HCF of 336 and 54 is equal to 2 into 3, and that is 6. Alright, now let's start the verification. So for verification, LCM into HCF, that is 3024 into 6 will give us 18144. And the product of two numbers, that is 336 and 54, that is also equal to 18144, and hence we say that LCM into HCF is equal to the product of two numbers, and it is verified. Alright, so I hope you're finding it easy, because this concept we have already learned, and therefore it is just the brushing up of the old concepts. Alright. Now children, here is the sum wherein we have to find out LCM and HCF of three numbers. Alright, so let's find out. This is question number 3, and from question number 3 we have selected second question. We have to find LCM and HCF of 17, 23 and 29. So we'll write down the number 17, 23 and 29. So let's start factorizing. 17 being a prime number, and same 23 is also a prime number, and 29 also a prime number. So the factors of 17 are 1 into 17. Then factors of 23 are 1 into 23, and factors of 29 are 1 into 29. So we have written the factors like that. Now we have to find out HCF of the three numbers, that is 17, 23 and 29. And if you see prime factorization of this three number, the factor 1 is common, and therefore HCF of 17, 23 and 29 is 1. Now what about the LCM? LCM will be 17 into 23 into 29, and that is 1133 9. Okay, so since the factorization was not much, this was easy sum. Let's move towards the next sum. So this is the third sum which we have selected. The three numbers are 8, 9 and 25. So let's first find out the prime factors of these three numbers. So we can factorize 8 as 2 4s are 8. Then we can find the factors of 4 as 2 into 2. And then we will start factorizing the number 9, that is 3 into 3. Then 25 we can factorize as 5 into 5. So we can just note it down. 8 is equal to 2 into 2 into 2, that means 2 cube. 9 is equal to 3 into 3, that is 3 square. And 25 is equal to 5 into 5, that is 5 square. Now when we have to find out highest common factor. Now which is the highest common factor here? The highest common factor of all the three numbers is equal to 1. So HCF of 8, 9 and 25 is 1. And what about the LCM? Now the least factor is 2. Its highest power is 2 raised to 3. So 2 raised to 3 into 3 raised to 2 into 5 raised to 2, that is the LCM, and that is 8 into 9 into 25, and the product is 1800. Alright, children, I will explain you one very easy method to find out the LCM of the three composite numbers without prime factorization, but that in the next video lesson. Alright, before that, just see this sum. You are given that the HCF of two numbers 306 and 657 is equal to 9. We have to find out LCM of these two numbers. Now the moment you come across, whenever you are given HCF or LCM and you have to find something, we will make use of the relation which I told you, that LCM into HCF is equal to product of two numbers. Now what is given to us? We are given LCM of the two numbers. That is what we have to find out. So we will make our formula from this particular relation. We have to find out LCM. So we'll write LCM of two numbers is equal to the product of two numbers. Now the numbers are 306 and 657. So their product will be 306 into 657 upon the HCF of two numbers 306 and 657. Now HCF is given to us as 9. So we will write 306 into 657 upon 9. We can cancel this. 9 ones are 9 and 9 into 73 is 657. Now when you multiply 306 into 73, you get 22338, and that is the LCM of the two numbers 306 and 657. Children, this particular relation is very important. Keep this in mind, that the LCM and the HCF of a given pair of number is always equal to the product of two numbers. Alright, so with this we will stop for today's session, and in the next session we will continue with the lesson. Till then, please keep revising, start doing your revision, because soon you are going to write your practice examination. So all the best to all of you, and happy Diwali to all of you. Bye and take care.